Hello everyone, my name is Xian Ruren. Today I'm going to talk about developing ultimate tomography for unique nanoscale insight into biomaterial. Bioactive glass is a group of surface reactive glass ceramic biomaterial, which is attractive candidate as they can simulate biological response and favor the bond formation. A new amorphous 3D strontium containing bioglass scaffold was developed as the right top picture shows, adding strontium to increase the bioactivity of this material. And the Purial characterization performed on this new scaffold shows the nearly perfect bone contact. However, it was unable to determine the location of release ions, especially at interface, leaving the mechanism of strontium uptake into bone and bone repair property unclear. The development of laser pulsing has expanded the use of ultimate tomography to a wider range of applications, which also including the biological material, such as bone-type material, tools, and also the interface. So we're thinking that ultimate could be helped to bring some new insights into this new scaffold. The motivation is to develop the specimen preparation, experiment, reconstruction, and data interpreted for biological material characterization, and then apply those techniques combined with other techniques like TEM to study the new scaffold and its interface. We have huge challenges such as sample preparation of biocomposite material and interface of ultimate tomography, and also the analyze and data interpreted of biomaterials with ultimate tomography will be challenging. So we start with the model material strontium 10, which is based on the clinic bioactive glass and contain 0.95 atomic percent of strontium. SM fit was used for size-specific sample preparation. We do the milling, lift out, and final shuffling them into the needle. We also avoid the cantilever loss by touching the molecule on the side of the cantilever instead of touching on the top surface. And we also optimize the parameter for the fit milling to minimize the electron beam damage for these kinds of beam sensitive material. As you can see, the middle one is the damaged tip. So we compare the different parameters of ultimate tomography to see the best running condition for these kinds of material and try to get sufficient spectrum counts. We found that the optimal temperature and detection rates for these kinds of material. As you can see, we do the experiment from the pancake to this good reconstruction. So after that, this is mass spectrum of the strontium 10 bioglass. We can prove that the strontium 10 works well in ultimate tomography and sufficient data was obtained. Mean peak can be confidently interpreted, or the expected elements was observed in the mass spectrum, and it's really a good one. Okay, and here we further compare the influence of the laser energy on strontium 10 data quality, such as increased laser power, we reduce the background level and improve the spatial resolution, and also more single charge of strontium obtained in single peak without overlap with higher laser energy. And we compare the concentration ratio of calcium phosphate with 4.65 when combining those analyzed together. We can see that the best or the optimal laser energy was between 200 and 250 picojoule. So this is one of my reconstruction under 200 picojoule laser energy. 3 tips was tested on the optimal parameter, all got successful and enough specimen counts. as the material is a pure one, so the reconstruction and the distribution of ions looks all the same from the top to the bottom. But it's really a good start for this kinds of material development of atom pop development in the atom pop tomography. So it's really a good start for this kinds of material as a model material. So here is my summary and my future work. So thank you for your listening.